going to start recording. So welcome to maybe the last public webinar of Global MLOps Day. So I hope you all have been enjoying our journey so far. So it's been a week. So we start with training process, then quality control, testing, importance of that. Then this week we listened to Alexei from OLX. Then we discussed about how to monitor data drift, etc. in the platforms. Then, yeah, we also saw how you can use reinforcement learning and how Glovo is leveraging that yesterday. So today, yeah, we'll be listening to Manuel. So Manuel is from Adevinta. So he is co-heading the machine learning services team there. I got introduced to him via Maxim. So special thanks to Maxim for, helping me in organizing this talk. So if I understand, I think they also have their own platform, and I think they serve probably close to 100 models. They scale their platform, so it's like a super good, interesting story that I'm also curious to learn from them. So thanks a lot, Manuel, for taking your time. I hope this session is going to be really, really useful for everyone who is attending as well.
Thank you very much. Honored to be here. Please let me know if you're seeing my screen and you can see the title of my presentation.
Yeah, we do.
Okay, that's fantastic. So yeah, thank you very much, Geo, and also to Maxim. It's really an honor to be here. So as I'm gonna talk about how we are democratizing machine learning in Adevinta, and yeah, my name is Manuel Sánchez. I am currently co-heading the machine learning services area in Adevinta, which is a central area composed by 4 teams. I've got the product responsibilities, and our mission in the area is make machine learning easy and impactful for all teams in Adevinta. Okay, so Adevinta, first let me give a few words to Adevinta. Is currently is the world's leading online classifieds group by revenue. So our main business is to build digital marketplaces all around the globe. And recently, since the merge with eBay Classified Group, which we acquired, yeah, we have become the largest group in terms of revenue. Our mission, and I think this is relevant also to understand the company, is to create perfect matches in the world's most trusted marketplace. So it's about matchmaking between people that are selling stuff, between people that are looking for new jobs, people that are looking for houses, for cars, and also in places where people can trust, and this is also very important. We have over 40 digital products, most of them marketplaces all around the world. For example, in Spain, we have Milanuncios, Fotocasa, InfoJobs, Coches.net. In Germany, we have Mobile. In France, we have Leboncoin. In UK, we have Gumtree. So they are all number 1 or number 2 in terms of market share in the country. And all these marketplaces that we have all around the world are served also by 4 central hubs, one in Barcelona, where I am now, another in Paris, in Amsterdam, and Berlin. These are the technological hubs that provide solutions to make the marketplaces faster, to make the marketplaces more effective, to improve the user experience, etc. So let me also show some numbers of Adevinta. In terms of revenues, I said before, is 1.6 billion euros, 7,000 employees. We have around 3 billion monthly visits, around 15, we process monthly over 15 billion events, and we serve over 10 billion images also per month. Well, I'm putting these numbers to show that we have, I think, substantial data, and we use this data to do machine learning. So why machine learning in Adevinta? What kind of things do we do here? So if you think about a marketplace, first of all, you need to have healthy supply and demand. No, so that means, for example, things like visual ad insertion, help users come to our marketplace using machine learning in SEO and SEM, object identification to help in the ad insertion process when someone wants to insert a classified ad. We'll see a bit more of that in a bit. Then another part of the marketplace is once you have a supply, you have healthy supply and demand. You need to make people find the objects or the items or whatever they are looking for. No, so you need to have great search and discovery processes in place in the marketplace. And here machine learning, of course, have an important role, by doing personalized search, visual search, recommender systems, etc. But also, on top of this, you need to add, and remember our mission was about trust also. You need to have safety in your marketplace. You need also to make the transactions very simple, no? And this safety is also an area where machine learning can help by, for example, detecting fraud ads, detecting content that is forbidden, like people selling animals or weapons or who knows, or things like a negotiator assistant, for example, done with machine learning to help in the negotiation, which sometimes is done through the chat system, not through the messaging system. So these are areas where some of the areas where machine learning can help. Currently in Adevinta, we are having over 200 machine learning cases, and we'll see also more specific examples later on. So let me start actually with so this was the introduction about Adevinta, machine learning, and now I'd like to speak about a bit of history. How was machine learning in the beginning of 2020 or at the end of 2019? So we had 8 teams doing machine learning. We had around 61 machine learning cases in production with value measured or with knowledge of value delivery. And we have, it took us around 70 days to build and deploy a machine learning model on average. These were some numbers. So the problem we had, so when our area also was created, the machine learning services area, is how can we efficiently, and by we I mean the company, build impactful machine learning at scale. These are, I think, this is the problem we were facing, and we were having a few challenges, no? And some of the challenges that we identified were technical, okay, in terms of maturity on experimentation, in terms of also maturity on machine learning infrastructure. So every team was actually building their own machine learning infrastructure. In terms also of data foundations, and by data foundation, things about data quality, tools to share data. You can think that a company which has 40 marketplaces spread around the world requires strong foundations in order to share data, in order to find it, to provide access, etc. And then there were other family of challenges, and here, this is some of the challenges. There were more than the ones I'm putting here, which were more related to knowledge. So, in the company, almost everybody agreed that machine learning was important. Almost everybody see machine learning as something that we need to do, but we were not doing as much as we wanted. And I think part of the reason was related to the knowledge gap. And the knowledge gap is not only of business people and business product UX people understanding how to manage machine learning cases and how to add machine learning in the product development process. It's also about the machine learning teams understanding the domain problems of the marketplaces, and also the engineers understanding how we should manage machine learning models in production, and how we should deploy them and maintain and monitor them. So that was these were some of the difficulties or barriers that we identified and that we wanted to act on them. So So what we did, so we started with a vision. Is actually the 3 years vision that we are still working on, which is this one. We want any team in Adevinta to be able to leverage in an autonomous way machine learning. And by any team, we don't only mean the teams that are doing machine learning, but any product team in a marketplace to be able to do that. And for that, we started a set of initiatives with the help of many other teams. And so this was a collective effort. So we started building a machine learning platform or integrating a machine learning platform. We built and we created a team that were doing reusable machine learning models. We nurture a machine learning community. We started a machine learning academy, and we also built a machine learning catalog. So let me go through some of these initiatives to give you an idea of what we did on each one. Now, the first one, and I think this also gives you some interesting examples of some of the things that we are doing in terms of machine learning, is that we built a set, and we're still building a set of reusable machine learning models. Why reusable? Think that having 40 marketplaces that we are serving requires it's very important, this reusability, and not only reusability, but also the capacity or the capability of integrating these machine learning models very quickly in all of our assets, in all of our marketplaces. So some examples that we built and that we also enable this capability is identifier of objects. So it identifies the object in an image, and also it's able to segment part of the image. So this helps search systems find better the items that are published in a classified ad. Things like background removal, which highlights the item that people are selling. Also a hero picture solution. So that means that it's able to suggest what will be the main picture, what should be the main picture of an ad, of a classified ad, and suggest that to the user, which is something that is quite used. We also built a, let me see if this can start, yes, a car recognizer that is able to identify the car that the person wants to sell and provide the characteristics of the car. And many of these models were built, not all of them that I was shown here, but many of these models were built in a way that they can be used in many of our countries and marketplace. And actually what we did is integrate that with the image delivery system that we have. So that marketplaces can integrate them in literally 45 seconds. We actually measured the time that a marketplace needs to add one of these models. So that reduced the time to deploy quite a bit. Okay, so that's one aspect that we work on. The other is the Machine Learning Academy. Okay, and the Machine Learning Academy was built to address the knowledge gap barrier. Okay, which we identified that is a barrier to scale machine learning. So in the Machine Learning Academy that we did in Adevinta is addressed to both business people. And here we did, so the kind of the content that people see here is, of course, an introduction to, so they can understand some basic concept of machine learning, how is the machine, how to do machine learning in the typical product development cycle, how to scale machine learning in the organization. This is mostly dedicated for business leaders. What techniques and use cases you can find in machine learning. This was one part, machine learning for business. And then we did another for tech people. So for programmers, where we show them how to build basic machine learning models, how to do feature engineering, how to put models in production. So we put as part of the content, so MLOps and how to deploy and maintain these machine learning models. So we ran this initiative in Adevinta last year, and over 200. Currently, actually, 250 new people have been trained on machine learning. 55% identify new machine learning use case that can be used in their domain, and the rating was high with 92% average rating. So people appreciate the course and felt it was useful for them. No? And yeah, so this is a second initiative that we did. A third one was the machine learning catalog. And here the gap that we wanted to address is similar. It's also about the knowledge, about people understanding which cases are being done in Adevinta, which and especially we put emphasis on the value added. No? Because in reality, we are doing machine learning in Adevinta to support the strategy, to add more value, to make our products better. So in this ML catalog, what we show is the different, we have currently 116 use cases, and what we show is each one of them, who did it, what improvement did it cause, what was the value added of it, where you can find the repository, etc. So yeah, so this was actually highly appreciated by many people, and indeed so this is inside what we call our research portal, and actually inside the portal, machine learning is the one that has the highest number of search from people, okay, of search queries. So this is the machine learning catalog, and now I'm going to speak about the machine learning platform that we built. Okay. So the problem, going back to the problem, is how can we efficiently build impactful machine learning at scale? And there is a fact that we need to acknowledge, which is that the time, the cost of machine learning infrastructure are high. Okay, we have estimated that our teams dedicated before having the machine learning platform around 40% of their time to infrastructure. So if a typical team has 7 people, 3-4 people were dedicated to building pipelines, to putting the models in production, to monitor the APIs, etc., etc. So this is a high cost, and actually, as many reports out there show, this cost is expected to rise. Why? Because currently, if people doesn't have the tooling, many of them are not doing model monitoring in the right way. Many of them are not doing retraining pipelines. They train the pipelines in a manual way when it's needed. So and these are needs. People has the need to do model monitoring. People has the need to do retraining pipelines. If they don't have the tooling, the time dedicated to infrastructure will rise. So what are the benefits? Actually the economical benefits for a team to have a machine learning platform, actually for a company to have a machine learning platform. Well, the first one is simple. It accelerates, and by accelerating means we can do machine learning faster because it increased the effectiveness and focus, and we could do more machine learning because by facilitating, by enabling people to do machine learning easier, you reduce the barrier for new teams to do machine learning. So that's one aspect of it. And the other, of course, is a machine learning will provide the needed tools that will enable teams to do things that were hard before, like model monitoring or retraining pipelines. And also, we have noticed how it reduces infrastructure workload. So this 40% that I said before can be reduced to 30, maybe even to 20%, by having a machine learning platform. So there is an economical value in terms of accelerating, in terms of more and generating revenue, but there is also an economical value in terms of reducing cost and giving focus to the team in the value and not in maintaining and tooling and keeping them. Okay. So how did we approach it? No, and I think the first question that came to us is shall we buy a machine learning platform, and embrace the third-party solutions, okay, that probably should be easy to do, maybe a bit expensive, maybe also we will have something that we don't like because we don't have control of the roadmap of this third party. It has some advantage and disadvantage. Or shall we build a machine learning platform, and go through the uncomfortable, through the painful path of all the needed work that we need to do, maybe with some light at the end of the tunnel. But in reality, there is a more fundamental problem than building and buying, and I think this fundamental problem is that when you build a machine learning platform in a company like ours, and probably like Globo and like other mid-sized companies, the machine learning platform is living within an ecosystem of tools in the company, like a data platform or a data mesh, like a data catalog, like some A/B testing platform, like some developers platform to put models in production. And in reality, what you want is that the machine learning platform integrates with all these products or all these other tools that you have. So the user journey to put a model in production and get value out of it and measure the value doesn't start and ends inside the machine learning platform, but starts and ends in other tooling that usually is part of the ecosystem. For example, probably the first thing that a data scientist will do is finding and accessing the data, then bringing the data to a place where they can work with. This is not usually part of a machine learning platform, but usually is a more part of a data catalog, maybe some data warehouse that you can build an ETL on top of it, etc. Then of course you need to do data preparation, building a model, and maybe do a hyperparameter optimization, building a pipeline. Yes, that is part of the machine learning platform. Then you need to deploy the model, then do A/B testing, probably part of other platforms. And this is a simplification of the steps. Of course, there are more sub-steps. So the question really is not so much building and buying, okay? And actually, we have seen, for example, in the case of buying. So if we buy a machine learning platform, we still have the problem of how to integrate it with the tooling, with the other ecosystem that we have. So we'll need probably to dedicate substantial efforts to do that. Okay. On the other hand, if we build it, what means building a machine learning platform? Do we need to build a notebook solution? Do we need to build a pipeline solution? There are a lot of open source solutions already to do that. So in reality, the problem is not building and buying. You can build some parts of it, you can buy some parts of it, but the real problem, if you want to make machine learning at scale fast, is to integrate the whole user journey. Okay. And by doing, and to do that, you can of course buy and build, or buy or take open source things that already exist, or maybe build if you're not satisfied with what you have. The real problem, how we see it, is really about integrating it to accelerate. Okay. So this is a first consideration. Okay. The second consideration, or the second set of consideration, is actually three important ones that we also tackled when we started this journey of building a machine learning platform. The first one is we have to acknowledge that machine learning teams are somewhat different. It's not the same a team that is building image recognition models than, for example, a team that is doing recommender systems. No, for example, an image recommender, sorry, an image recognition model. An image recognition model requires high throughput. Requires well, probably a lot of memory. The model itself usually are models that are very heavy in memory, compared to, I don't know, to another team that maybe is doing simpler models, maybe with a bit with NLP or maybe with tabular data, which usually don't require so much throughput or so much memory, or with a recommender system that requires very heavy workloads in terms of data. So this is one aspect that we needed to acknowledge, okay, when we started our research and so on. Another aspect is, you know, that, as I said before, there exists a huge amount of, well, a very big amount of tools to solve many parts of this user journey. In reality, I think in the ML tooling space, it's quite immature, and I think you can see that in this graph, which shows the number of ML tools, the cumulative number of ML tools that that exist year over year, and how it grows. And I think that, you know, and this is important, no, because if you are gonna integrate different open source tooling, you need to acknowledge that first, they are immature, and secondly, as a consequence of that, in 2 years, there will be something new that your data scientists will like, that your data scientists will want, that probably is more effective. So you need to take that into account. Okay. So that's the second aspect, and the third aspect is that you don't want to spend, you know, 3 years building a machine learning platform and then bring it. Of course, we are in the world of agile. You want to provide value bit by bit. Okay, so these are kind of 3 constraints or 3 aspects that we acknowledge from the beginning. No, we want to have a machine learning platform for many different teams. We want to leverage and integrate existing tools, open source or things that we buy. And we want to be also flexible on these tools if we want to change one by another, because it's changing. And we want also to deliver value bit by bit. So you know, so we have very clever engineers in our teams. They were thinking about how to tackle this problem, and that's how our platform, which we call Unicron ML Platform, was designed. It was taking into account these 3 aspects. No? And so what is our ML platform? Our ML platform, it's based on something that is very composable and scalable. So I assume this is ringing some bells in some of you. Know what is composable, scalable? It's based on Kubernetes. Okay. So by doing it on top of Kubernetes, it allows us to compose different tools and integrate them. And also the fact that we can put these tools one by one allows also to deliver value bit by bit. And also the platform is, this infrastructure is managed using GitOps. Okay, so GitOps allow us to do something that our teams, or machine learning teams, appreciate a lot, which is that the solution, that the machine learning platform that we provide, is a single tenant solution. Your team will use it and will not share it with other teams. And your team, if you want to change one of the things that we give by default, you can do it. If you want to build on top of it, you can do it. And we will, our teams or the machine learning platform team will basically maintain the infrastructure that is behind. So updates that you want to do or that need to be done in terms of Kubernetes, security patches that needs to be done. All of them will be monitoring of the infrastructure. All of that will be maintained by the team, so that you as a machine learning team, as a data scientist team, can focus on doing machine learnings and deliver value to the marketplaces. Okay, so that means that we have a single tenant solution, as I said, based on GitOps and Kubernetes. GitOps is actually providing the definition of the infrastructure that should go into Kubernetes. And what we provide, so when we say Unicron ML platform is not a single platform, it's actually the capability to provide platforms that are single tenant to each team, okay? So each team will have its own instance of the platform, and they can customize, they can activate things, deactivate things, they can actually build on top of it, as I said before. And this also is fantastic to acknowledge that you know, machine learning teams have different specific idiosyncrasies and needs, and this is how it's tackled. Okay, so going back to the user journey, what specific tools are now integrated into our machine learning platform? Well, it's not difficult. So currently for data preparation, we're using Jupyter. For building the model, hyperparameter optimization, people use Katipa. Well, we have Katipa and Optuna there. For building the pipelines, teams have decided to put Kubeflow. And as a model store and a first step to deploy the models, the users have decided that they want MLflow. And this is something also, I think, an important aspect of the platform, or how the platform is built, how the team approach it, is that the roadmap of the machine learning platform is actually driven by the community. So they are the ones that form what we call expert groups. For example, if we want to tackle the model store, no, let's have a model store. There are several options. No, you can have, for example, SageMaker, because we are actually working on top of AWS. They have some model store capabilities. You can actually use MLflow, or you can use actually Kubeflow also comes with something like that. No, so what the community did is they created like a little group of experts that look at the different tools, and they decided that MLflow is the best one that we want, that is better for their needs. Okay, so what the ML platform team does is integrate that into the user journey, integrate that into and provide it to the user. So we have, our users are happier because they get the best, what they believe is the best, and we can provide more value to them. Okay, so this is in terms of so to summarize, these are the set of actions that we started at the end of 2019. You know, a machine learning platform, reusable machine learning models, and nurturing a machine learning community and working close to them to provide more value, a machine learning academy, and a machine learning catalog. And how have we evolved? Okay, so as I said before, we used to have 8 teams doing machine learning, 61 models in production, 70 days to deploy machine learning model. We evolved to 16 teams currently currently is more, because I am not counting here the integration with ECG. So 16 teams doing machine learning in the legacy Adevinta, 150 machine learning cases in production. So we went in 4 years, we built 61 machine learning models as a collective effort again, and we moved to 150 machine learning cases in production in 1 year. And we reduced, not as much as we wanted, but a bit, from 70 days to deploy a machine learning to 50 days to deploy a machine learning model. And I said, but you need to consider here that also there are 8 new teams doing machine learnings with which they are ramping up their capabilities. Okay, these numbers again are not counting ECG integration. Actually, there are more than, currently we are approximately more than 130 people working on machine learning in the company. And we have over 200 machine learning cases in production if we count ECG. So that's all from my part. So I am very happy to take some questions. I see that there is something in the chat. I think there is a question already, isn't it, Cheo?
Yeah, we do have a question already. So thanks a lot, Manuel. anyways, before we go into the question, I want to say this is super interesting and inspiring presentation for myself. So I think, yeah, the first question is around the stack, the technology that you use for A/B testing, and yeah.
This is a very good question. So we have our own platform, our own A/B testing platform. Although there are a few other marketplaces that are using third-party ones. Okay, so yeah, we have an in-house platform with some adoption, and we have also some third-party. So we haven't converged yet towards a single platform.
Okay.
And of course, we haven't done that yet, but we aim to integrate our machine learning platform with the central A/B testing platform. Yeah. So there are some integrations that we haven't done yet, and this is one. Okay, but we are planning to.
So this A/B test essentially would include the UI toggles plus model-related A/B testing as well, right?
Exactly.
Okay, cool. I think there is another question around the team structure, like okay, how many team members are in MLP team in Adevinta, and how you grew it. Yeah.
We have currently around 40 members in the machine learning services area, in this central area, divided in 4 teams. 2 teams doing machine learning solutions, recommender systems, and image recognition solutions. 1 team is doing is actually the image provider, is the media service provider, which we are also coupling with the image recognition team, so that to accelerate all these integrations. And there is a 4th team that is, of course, building the machine learning platform. The team has grown from 30 to 45 people that we are now in the last year. But this is not the only team or area doing machine learning. You know, we have also, as I said, 16 teams, actually more with ECG, around 21 or 22 teams doing machine learning, and over 130 people.
Perfect, thanks. I think there is another question around what is actually the main time consuming factor when it's 50 days to deploy a model.
It's a very good question, and we have studied that. So we have researched that, but we learned that it varies substantially from team to team. So the way we define, actually the total time to value is higher in our company, because time to deploy machine learning, we have defined it since the team has access to the data until a solution, an API or an automated solution is deployed. But before that, you need to get the data, which that takes time. And after that, after you deploy the model, you need to, integrate it into your marketplace and do some A/B testing. So actually the real time to value is higher than 50 days. Okay. And I want to say that 2 major pains in Adevinta, so you can imagine that Adevinta is not a simple company, in the sense that it's composed by 40 marketplaces. Some of them have been purchased, some of them have their own stack, even their own data platform. So 2 major pains in the company for data scientists and for any almost a data analyst also is finding the data and data quality. Okay, so this actually acts outside these 50 days that I mentioned before, and so that there is some time there. Now inside the time to deploy machine learning, there are several aspects, and they are different depending on the team. One, of course, is improving the data or bringing the data up to a certain quality that it provides models that are good enough. Data, the quality of data is the main factor to have a higher quality model, and so this takes usually a lot of time. Sometimes they need to label data. You probably know the story. The second part is mostly is also related to product discovery. That's mostly related to to working close to product to understand what is the need, to change in the product definition, etc. That also has caused some time. But I would say that yeah, data quality and spending time on the data has been one of the major factors.
Cool.
Currently, putting models in production doesn't take so long. I mean, it's just building an API. Sometimes when the specific model is hard because, for example, it's very big, etc., they sometimes struggle and they need to find a solution. But this usually this is a problem that is solved. Building the retraining pipelines, this is usually done after the model is in production. So these are not major factors of paying now.
Yeah, just as a follow-up question, when you're answering, I was thinking, is there like a way that you track this end-to-end life cycle? Like
Yes.
I saw that you have the catalog. So then you are using distributed tools. The same challenge in Glovo is that we also have distributed tools. Then when on a business level, when we want to say that, hey, it took X days for a model, these metrics are scattered, and how do we do the reconciliation, right?
Yes, it's a great question, and how we are doing it now is we are using the input of the people to get this number, and we are getting it through the catalog actually. So in the catalog, we ask the people, okay, when did you start building the model? When did you finish? And we believe it's, and usually it's true. I mean, we are averaging it and so on, but of course it's not the best way of doing. So the numbers that I'm providing here are an approximation to the reality. What we are currently actually doing or starting to do is measuring it inside of the tooling that we have. I mean, it's what makes sense. Once you start, you receive the data inside the ML platform, and we should actually do it in the whole flow. Since you want to find the data, since you start in the data catalog until you put the model in production, no? In the whole flow is where we should do it. I see another question from Oriol. Do you have a customized solution to deploy your models? Okay, we are currently working on that. So we use partly, so the way we are using, or we are about to finish this, we are testing it. The way we use MLflow is mostly for the as a model store. That means as a way to look at the results of your model and understand which model is better, etc. Once you have it, the team is building a pipeline to deploy the model. Well, we have done that already, to deploy the model into what I call it the development platform. It's not, we call it the common platform, which is the place where our microservices reside, where many of the Adevinta microservices reside. So if you want to, so you can actually automate. So what we are doing is the model deployment is partly using MLflow and partly using the systems of Adevinta, where we put the microservices. No? Another aspect that we of course need to tackle is the specific monitoring for the models. No, like when you put a microservice there, of course you need to monitor certain things that everybody knows and that we do. But then so typical from microservices, no, throughput, uptime, etc. But then for a model, you need to do some specific monitoring in terms of the data that come in, the data that get out, and this is also complex because you want to do it also at like distributional monitoring of it. So this is something, a topic that we are also need to tackle. Do you use any mesh solution for the infra Kubernetes platform? I'm not sure, to be honest, what is a mesh solution, so I guess no. But yeah, sorry, Rafael, on this question. So, but basically, maybe I can answer. I'm not sure if this will provide the answer, but the way we use Kubernetes, we are working on Amazon Web Services, on AWS. So this is our cloud provider, and what we do is we use EKS, which is one of the services of machine learning platform that to provide Kubernetes cluster. On top of EKS, which is a managed Kubernetes provider, we built a set of, well, we built all the tooling. What we say is that we provide Kubernetes on batteries. And actually, the tooling that we provide on this Unicron platform is to do machine learning. So it's a machine learning platform, but it also has a very important part, which is to do big data jobs. Okay, so to process big data jobs that are actually usually done in, for example, in recommender systems or so on.
Cool. I think that's the questions. I think just a follow-up question from me. I think you didn't mention much about the monitoring dashboards part. Do you use the catalog as there is like a drill down to this catalog where you can see the ongoing monitoring?
Not yet.
Yeah.
We have in the catalog, we have two things that, of course, you have a link to the repo. It's a first version of the catalog.
Okay.
We're evolving it, but we have a link to the repository where you can see the code. We have also sometimes a link to a demo page, like where you can actually demo the model, and with a little app you can see how it works, etc. In terms of monitoring, most of the models are monitored. We don't have a unified monitoring solution for models yet, so every team is doing it. But this is a topic that will come, that is in the roadmap.
Okay. And the observability, since your platform is distributed as an atomic units, they do it by themselves, right?
We have actually the common platform where the models are deployed, where any actually microservices deploy has observability by default. I mean, has certain observability already. So part of the observability of the microservice is provided by default in this second platform. That's why so when a machine learning model is deployed there, automatically you will have the part of this observability solved. Now there is another part of monitoring a model, which is, for example, the degradation of the performance of the model, etc. This is not solved yet.
No, okay. Cool. Sounds good. Just one last question from my end would be around, integration, how coupled you are with data warehouse and data lake, and, how the data catalog, do you use any feature store there to store your features, or is it managed separately there? Yeah.
So we, there is a central data catalog called Data Hub that not only is used as a data catalog, but is also used as a service to manage accesses and also comply with GDPR, which is coupled. So if you access a data catalog, you can, to certain data, you can of course use it in Unicron. No, this is solved. And actually, Unicron is part of the data warehouse solution, of the global data warehouse solution. Okay, which includes tools to do data quality, tools to share data, etc., and tools to do big data jobs, which is Unicron. So that's the level. However, we are working to further integrate that. Okay, as I said, one of the things of this company is that is the level of complexity and heterogeneity that we have in the marketplaces, and that from a data fundamentals perspective introduce management. But yeah, this is work in progress, and now with the complexity of adding a very big company, which is almost of the size of us, of 3,000 people more, which is ECG, what we are merging with. We are actually currently on this whole process of how to put the data capabilities together, etc.
Perfect. I don't see any other questions, and I think it was a super useful session. I hope everyone in the call enjoyed the session as well. So if you are watching it after this session as a recording or in YouTube, and in case if you have questions, don't hesitate to reach out. Yeah, I think this will also mark the end of our a week long of sessions. I hope everyone enjoyed, all the webinars we did, and hopefully we will publish some notes in our global engineering blog, and then you can follow up as well if you have more questions. Happy to answer all your questions, and all the recordings would be shared next week. So we will share the recordings and presentations, the available ones, next week. Once again, thanks a lot, Manuel, for taking your time. It was very useful presentation and really insightful for myself as well. Also, special thanks to Maxim as well for helping to arrange this talk with Manuel.
Happy, very, very, very happy and honored to be here. Really a pleasure, and thank you also for the questions.
Thanks everyone. Have a nice evening. Bye.
Okay, goodbye.